Okay, now we go to the next part. This is task 1, question 6, and then we go from 1 to 6. 1 to 6. The characteristic gas equation is PV equal nRT, where P is the pressure of the gas, Newton per meter squared, N is the number of molecules, R is the gas constant, and T is the temperature in Kelvin. Work out the problems below. The first one, we have the pressure of the gas, we have the volume, we have the temperature, and we want to find what is the number of molecules N. PV equals nRT, so N is going to be PV over RT. So it's going to be the pressure 20 times the volume over R times T. R is 8.3 roughly, so that's going to be 8.3 times the temperature, which is 600 Kelvin. So the numerator is 40 over, and then you do the calculations, 8.3 times the temperature, so it's going to be 4,180, and this is in moles. The measurement is in moles. We do the same approach here. PV equal nRT is my initial equation, and we want to find the pressure of the gas, so the pressure is going to be nRT over V. N is the number of molecules, 10 to the power of 7 times 8.3 times the temperature, which is 800, divided by the volume, which is 4. And this is Newton per meter squared. So it's going to be, let's do this calculation. 10 to the power of 7 is here in the numerator, times 8.3 times 800, and then you divide by 4. So it's going to be 1660 times 10 to the power of 7 Newton per meter squared. The pressure is very big in this case. Let's go to the next problem. We want to find the volume of the gas, PV equal nRT. So V is going to be nRT over P. The number of molecules is 10 to the power of 8 times 8.3 times the temperature, which is 650 Kelvin, divided by the pressure, which is 25. So that is 10 to the power of 8 times 8.3 times 650 is 5,395, and then you divide by 24, so that's going to be 224.79 roughly times 10 to the power of 8, and that is going to be in meter cubed. That's a big number because of the parameters here. We have big pressure, the number of molecules is high, and the temperature is very high. Now let's go to the problem 4. We want to find this quotient, so what we have to do, PA VA over PB/VB is going to be nRTA over nRTB. This will simplify and we will have TA over TB. And then TB equals 20 TA, so we substitute here. TA over TB is going to be 20 TA, so that's going to be 1 over 20. Which is less than 1. Or you can write this, that you can write the following, that PA/VA is less than the product of PV/VB, or you can write it in this way. Now let's go to this one. We have the characteristic equation for gas A and gas B, and we want to find that if this relationship holds between NA and NB, what is this quotient PA/VA over PB/VB? Again, we work in the same manner. We divide these two equations. This will simplify and we have NA over NB. NA is 30 times NB. We can substitute in the numerator over NB. So that's going to be 30. Of course, if this is bigger than 1, which means that PA/VA is bigger than PV/VB. And we derive this inequality. Now for the root cause analysis, you can do independent search online. And try to find appropriate information to build up your answer for this part.